Welcome everyone to Fail Safe Printing. Say goodbye to user error with Dr. Nitish Surathu. My name is Julia and I'll be your host today. So it's a big pleasure to have our guest speaker here, Dr. Nitish Surathu, who is an expert in 3D printing and has been an Ackuretta user for, I think, over 1 year now at this point. Before we get started with the presentation today, I'd actually like to already call out our upcoming events. So right now, my dear colleagues in the United States are actually at Thrive Live, the Las Vegas event. So you can find us actually at booth 112. So if you're currently actually in a casino in Las Vegas, come stop by the Ackuretta booth. And then next week, we have a really exciting event that I'm sure everyone knows about as well, is the Lab Day West in the United States. So if you are around there, feel free to sign up to our lecture with Eugene Roisengert, who is a denturist adjunct faculty at the ADC. Fantastic guy, and also an avid Ackuretta user, and he'll be co-sponsored there by PacDent and us. And so we're really excited about that one. And there will be CE credit available for that class. I'll be sharing those links in the chat later. And then we have another webinar actually also coming up with Dr. Surathu from Scan to 3D Print for dental model printing, and that'll be May 18th. So a lot of exciting things coming from our side and a lot of opportunities for everyone to learn about 3D printing and maybe to get more familiar with their equipment that they already have. 3D printing, I think, there's always more to know. There's always more to learn. And, materials never stop coming out. And the cool thing about Ackuretta is that we are an open system that does validations, which means you don't have to do the work. We do it for you. And in the end, you get great results. So just on that, I'll send all these links later in the chat. And now I'm very excited to introduce our guest speaker for today, Dr. Nitish Surathu. We've worked with him multiple times. You may have seen him around. He's a fantastic speaker. That's why we like to invite him back. He's currently in Charlotte, North Carolina. He's a periodontist practicing in New Zealand, but is actually lecturing all around the world. And he's an accredited associate fellow of the American Academy of Implant Dentistry and a fellow and diplomat of the International Congress of Oral Implantologists. He's currently part of the he's currently a director with the ACE Institute, and he's formerly a executive council of the Asia Pacific Society of Periodontology. I'm saying a lot of these things wrong. Nitish, feel free to correct me. Anyhow, I'm excited that he's here because his experience in CAD/CAM dentistry is probably unparalleled, and we're excited to have him here. And look forward to your lecture on how to avoid all user error in 3D printing. So thanks for being here. Thanks for doing this. And with that, I will hand it over to you, Nitish.
Let's start by saying that this is a great topic. I really commend Ackuretta for being willing to talk about this topic, because it's almost negative in its connotation, and it's almost something that nobody wants to talk about or say anything about. Every company likes to pretend there's never any failures, and that really is not true. If you've been 3D printing for any duration of time, and I've been 3D printing now for about 5 years, I've been working with the Sol actually for a little over 1.5 years now. And it's one of the printers that I use. And do I see failures? Absolutely. I see failures with every printer that I work with. Usually it's my fault. And after printing for 5 years, I've gotten better and better at eliminating what you might call user error, which is the topic of this presentation. And so I am going to focus on user error a lot, and that's not really any kind of accusation against any of you. It's about getting better at what we do, and in that sense, it's a positive direction to take, acknowledging that sometimes we do things wrong, sometimes things do go wrong for various reasons, and it's about fixing those reasons, and it's about getting better outcomes for ourselves and for our patients as well. And so let's move on. So after printing for 5 years, what have I learned? Failures do happen. And Printing failures are sometimes multifactorial. They can have to do with the temperature of the room. They can have to do with the resin you're using or the profile that you're using. They can have to do with the settings on your slicing software. You can pick the wrong resin profile and be printing in a completely different resin altogether. How do I know that? So there's all kinds of multifactorial reasons why printing failures can occur. I'm not going to pretend that I'm going to address all possible causes today, because that's simply not going to happen. There's so much to 3D printing failures that we really can't get it done in a web presentation like this. On my 3D printing courses, I discuss failures for a good 2 to 3 hours, and then we talk about what we can do as well. And so it's not something that I can cover every aspect of. But really, the best way I can approach this is by trying to give you a systematic understanding of 3D printing. I'm going to take things in a sequence of sorts, and I'll tell you what I mean in a moment. And we'll work through the same systematic sequence when our prints fail. So I've got a logical step-by-step sort of understanding of 3D printing, and I go in the same sequence when I want to figure out why a certain print failed. So that's really what I'm saying. So 3D fundamentals, and I think these are the most common reasons we see failure. If you get some of these things right, you're already setting yourself up for success. The environment in which a 3D printer lives is extremely important. Temperature is the most important thing, of course, for a 3D printer. Most companies like to say 18 degrees, but honestly, in my own experience, I think the room needs to be somewhere between 20 and 25 degrees. Now, that's easily achieved with an air conditioner in the room if you're in a very hot country, or with heating in the room if you're in a very cold country. But it's quite easy to actually create that environment, and 3D printers do best, and resins do best in that particular temperature range as well. Resin temperatures are also important, and I see that as separate, because you could have your printer in one room, you could be storing your resin somewhere else, and then bringing in a very cold resin when you want to print, and that in itself can cause failure. With some resins, especially filled resins, it's important to mix your resins as well, because there's a supernatant and filler particles tend to settle at the bottom. With some of the resins that are compatible with the Ackuretta Sol, this isn't as critical as it is with some brands. With some brands of resins, I've actually had things like hot dog mixers, actually constantly stirring a bottle in order to keep the homogeneity of the resin intact. You don't need to do that with any of the resins that are available for the Sol, but certainly a good idea to mix resin. And I would do that mixing very gently. Don't vigorously shake the bottle and create a lot of bubbles in the resin itself. But yeah, very gentle shake. Just make sure that the filler particles get equally distributed in the resin base. Fundamental things that I would check definitely are the build platform and the VAT as well. I can't tell you the number of times I've had well, not a number of times, but I've seen it happen a couple of times. My build platform screw is loose, and therefore my Z-axis is affected, or my build platform hasn't been fully seated in its slot. All of these things can contribute to failures. With the VAT itself, with the Sol, it's quite difficult to get the VAT into the wrong position, because you've got nice dimples on that printer to align the VAT very well, and you've got very nice locks that don't close until you've got the VAT in the right position. But it's possible to check the resin profile selected, because every time there's a software update, I've seen this happen so many times. The software can auto select a certain resin profile because the settings are set to use the last profile that you used or something like that. Just make sure you are on the right resin profile. And when you actually generate a slicing file, just make sure you're dealing with the right resin before you start printing. Finally, check the resin level in the vat. If you're printing something that's particularly large, and let's say it's a solid structure, it's not hollow, it's going to consume a lot of resin, and sometimes you can have failure because there's just isn't enough resin in the vat. So make sure you top up, make sure you're at that max line. You also want to be careful about not having too much resin in the vat, because if you exceed the max line and the resin spills over out of the vat, that's not a good thing for your printer either. Make sure as well that you have up-to-date firmware. Sometimes companies are constantly improving things. So in terms of the Curie, or in terms of the Sol itself, there could be firmware updates, and you want to be up to date with those firmware versions as well. So once you've got these basic things in order, you're usually good to go with printing. Now, I did say that we would go in a sequence of sorts, and I'm really going to take this approach. So this is the sequence I'm going to follow. This is basically in a vertical order. These are what you see in a printer. So we see the build platform first, we see supports on a print next, you see the actual print itself there, you got the vat below that contains the resin, and under the resin, of course, there's a film, and there's a light source under the film, which in the Sol's case is a bunch of matrix LEDs, and these cure through the film, and that's how you get your resin to harden layer by layer as it additively manufactures whatever you've thrown at the printer in terms of wanting to print. So we're going to follow the same sequence. We'll go in this very same order. We'll talk about the platform, we'll talk about supports, the print, the vat, the resin, the film, and eventually the light source. And all of these can be a contributor to a failure. And so there are some basic things which we need to get right with these things. Before we do that, however, let's get a fundamental understanding of the multiple axes that exist in printing. If you talk to people who are very familiar with 3D printing, you'll hear them talk about XY resolution and Z-axis resolution, Z-axis calibration. So let's put some of these terms into place. The XY is basically the platform's width and the platform's length, and I hope you can see that on my screen right at the bottom. So the X and the Y basically define the size of the platform. The Z-axis really is the path along which the platform moves, and so the platform goes up and down along the Z-axis, and that's how it brings the platform in contact with the resin. And in the case of the Sol, that's about 140 mils, and so it's a pretty significant volume that you could print. Technically, you could print anything that is within that Z-axis volume. So you could print something that's technically within 140 mils. I'm not saying you necessarily do that, but it's potentially possible. The size of the build platform of the vat of the Sol is about 128 by 80 mils, and that gives you a rough idea of what you can fit in terms of that size of platform. But hopefully you've got a good understanding of what we mean by printing axis. And so when you look under the vat itself, if you took the vat of your Sol out, underneath it you would see what's called the LCD screen. This LCD screen basically creates a mask. It's a monochrome mask, and the mask basically decides what parts of the resin receive light from the light source and what parts of the resin don't. So if you look at your slices on the screen of the Sol, after you've generated these slices in slicing software, and after you've taken the file, the IBF, into the printer, and you've given a print order, you'll see the serial slices that the printer is going through. And of course, you can view these slices on the Alpha AI software as well. And basically, these slices are Each of those will show you something in black and white, and that black and white is really a representation of what the LCD mask is going to look like. So fundamentally, the areas that are white are where light is let through, and the areas where you see black is where the light is masked. And that's really how an LCD LED printer works. So the light source in the Sol's case is an LED light source at the bottom of that LCD mask, and so that's fundamentally how things work. Now, if you're really sharp, you'll notice that I'm printing a surgical guide, but then I'm using a cast profile on this particular print, and that was purely for experimental purposes. I test a lot of stuff, and I was working with something that I wanted to test, and so don't be surprised by that. I'm well aware that I'm using a castable profile there, but that I'm using a resin that's completely different altogether. But in your case, if you were not testing stuff like I do, and if you're not experimenting, if you were doing a regular print, that resin profile and the material that you were and the application that you were using it for would have to be in sync, of course. I don't have to tell you that. So that's the LCD screen right there. Now, it's very important not to get resin into this area. If you get resin spilling over from the vat, or if you have leakage from the film of your vat, if you get resin on the LCD screen and it gets in around the sides of the LCD here, you've got an expensive repair job and maybe even a printer replacement coming. And so I know that's happened. And in fact, there's a picture of one from the Ackuretta user group in this presentation later. So this is what an LCD LED printer looks like in terms of a diagrammatic cross section. But I've really explained most of that, so we'll move on from there and look at the next slide. Now, when the most fundamental failures, the most common failures I see are build platform failures. Probably build platform failures and support failures are the most common types of failures that you will see. Now, the most common build platform failure that you will see is you will see that there is nothing on the build platform after a print has been completed, and you notice that there's a layer of resin at the bottom of the vat that is still sitting there. If you see these failures with transparent materials like guide resin or splint resin, it's very obvious to see that layer that's still adhering to the bottom of the platform. But if you've got an opaque resin like this gray resin here, then sometimes that's not quite as obvious. But be sure that every time you have a printing failure, if you don't see anything on the platform, always check if the vat's got something in it. If the vat doesn't have anything in it and there's nothing on the platform, that's a different type of failure altogether, and we'll talk about that. But in general, if you do see something at the bottom of the vat and you can carefully pick up a layer of printed resin like this, like you can see in this picture, then typically this is where the cured resin did not adhere to the build platform. And that happens for several reasons. The most common reason why that happens is because there's insufficient light exposure for whatever reason. So for example, if the curing intensity of the light for that layer is not high enough, then the resin won't adhere to the platform. You also have to understand that every time the platform comes down and the platform reaches the bottom of the vat, essentially the platform maintains a distance from the bottom of the vat, which is approximately equal to the thickness of the layer being printed. And you guys know that you can select that in the AI software, in the Alpha AI software. So you could have 50 microns, you could have 75 microns, whatever it is. The platform essentially descends down the Z-axis, comes into the resin, encloses a layer thickness that is equal to whatever you've selected, and then the light shines through the LED mask, and then it cures a layer of resin. That's essentially what happens. The minute that cure happens, if the intensity of the cure of the light's good, then the resin will adhere to the build platform. But the minute it adheres to the build platform must then withdraw from the resin. It needs to move out of the resin again to allow the resin to settle to a horizontal level again. And then it comes back for the next layer. So when it prints the first layer, the platform is approximately is away from the bottom of the vat by the layer thickness that you've selected. So if you selected 50 microns, for instance, the platform would be 50 microns away from the vat. When it moves away with that layer and it comes back for the next layer, it's now 100 microns away from the vat. But between a printed layer of 50 microns and uncured resin of 50 microns, what it's going to now cure is another layer of 50 microns that is going to adhere to the first level of the first layer that was printed and stuck to the platform. So I hope you kind of understand that. It's hard to explain 3D printing in words, but I hope you get the idea. But every time the platform moves in and out of resin, the printed layer that it achieves is something that tends to want to stick to the film of the vat just as much as you want it to stick to either the platform or whatever has already been printed layer by layer. And so the film's constantly fighting the platform in one sense. The film's constantly trying to pull the print away from the platform. And this is a battle that's going on constantly throughout the time the printing is taking place. And so we call that a peel force. So you have a force by which you peel the printed resin layer away from the film. And that's really what we're talking about when I say we call that a peel force. And so the peel force is dependent on multiple factors. You could have film that's at the bottom of the vat that's not too sticky, and that will lower the peel force. You could also have a small platform as opposed to a big platform, and a small platform will have less peel force simply because it's printing a smaller layer. But regardless of what you're doing, look always at the cross section of the layer that you're printing, and that shows up in your slicing software like this. So if you've got a large cross section or a large layer printing at one go, then you're going to have more peel force. Bear in mind as well that if you print multiple small objects across a large platform, then each one of them is generating peel force as well. And just because you're printing small objects doesn't mean that the peel force can be lowered, because the number of objects, the multiple nature of the objects, again adds to peel force as well. So these are things to take into consideration. Finally, your platform needs to be nice and rough as well, for that cured resin layer to stick to it. And in the past, we used to see printers, I think some of them even do this even today. You're actually provided sandpaper where you could roughen a platform. With Ackuretta, all of the platforms that you get now, you have solution-based platforms or application-based platforms. So you've got small, medium, large. The small is great for crowns. Medium's great for anything that's a single arch, and the large is great for anything larger than that, really. But all of these platforms come with what's called hairline anodization. The anodization doesn't cause the hairline nature. The anodization is there because you want to prevent abrasion of the platform by filled particles like ceramic in some of the crown resins that the soil is compatible with, like patent rod and sculpture that I print in a lot. The anodization therefore prevents the metal from leaching into a ceramic filled resin and causing discoloration. The hairline nature of the platform, however, is a physical characteristic, and it's got nothing to do with the anodization, as I said. The hairline nature of the platform actually ensures that the platform is sufficiently micro rough in order for prints and layers of prints to adhere to it. So this is taken care of very nicely with Ackuretta platforms. Bear in mind that Ackuretta has 3 different sizes of platforms, was probably the first commercial printer to come out with options with build platform sizes, and they did this quite a few months ago. Now, if you're using a smaller platform, the peel force is going to be less because the cross section of the layer is going to be small, because you're only going to be able to fit something small on a small platform. And so if you've got a small platform, it will print much faster as well, as a consequence of the fact that the peel force is less because of the cross section of the layer being small, as I said. And so that's something to take into account as well. So if you're printing with any of these platforms, be prepared to see an increase in speed as you go down the size. It does, however, depend on what kind of resin you're using. You don't necessarily see significant increases in or decreases in speed with highly viscous resin, so be mindful of that. Doesn't happen with every resin, but it certainly happens with some resins. And I'm certainly driven to select my platform based on my application nowadays. So small platforms also displace less liquid, less resin. And so if you've got a large platform going by Archimedes' principle, the volume of resin that is displaced each time the platform comes down the z-axis into the resin vat, it's pretty significant. Now, if you displace a lot, it's going to take more time for it to bounce back to horizontal normal before the platform can return for the next layer. So be aware of that as well. So if you're using smaller platforms, they displace less resin. If they displace less resin, the resin can come back to normal much quicker. If it comes back to a horizontal level much quicker, it eventually means that the platform can return for the print back to the vat. The platform can come in faster. And all of that translates into much quicker printing. I did talk about z-axis. I did talk about the platform so much, and this is perhaps the appropriate point to talk about a very, very significant failure, or rather a very, very significant cause of failure. You can sometimes throw your z-axis out of gear. What do we mean by that? Well, the z-axis is really the path along which the platform moves down and comes down into the resin and into the vat. If your slicing software is saying that each layer is 50 microns, then your platform is going to maintain a distance of 50 microns from the bottom of the vat. In other words, it encloses a layer of 50 microns. If, however, the platform is saying 50 microns the software is saying 50 microns and the platform is not doing 50 microns, but it's doing 100 microns, for instance, then your z-axis is out of gear. Now, Sol comes pre-calibrated. You really don't have to do z-axis calibration with the Sol unless you actually have a problem. And if you have a problem, I suggest you get in touch with tech support, because doing z-axis calibration is not difficult, but it's a bit involved. And so you might want support from the technical team before you do z-axis calibration. But let's talk about what can throw your z-axis calibration out of gear. The most common thing that could throw your z-axis calibration out of gear is when you have debris left in the resin from a previous failure. So there are bits of resin left behind. You haven't cleaned your vat properly, and that's something we're going to talk about at the end of this presentation. What do you do when you have a failure? How do you clean your vat? Because I think that's very important. But if you've got debris at the bottom of the vat, then think about it like this. The platform comes down into the resin of the vat, but the debris in the vat prevents the platform from seating to its full extent, if you know what I'm saying. And if that happens, then the platform is misled into thinking that that's the bottom out, if you like. And so that throws your z-axis calibration out of gear. You can also have z-axis calibration go wrong if you have a loose platform or if you have incorrect vat position. Very rarely, and I really haven't heard of this ever, but it's technically possible that the shaft down which your platform goes up and down could be insufficiently lubricated. I've never heard of this happen, but I guess if you're using a Sol for 3 or 4 years, at some time that shaft may need lubrication. In all of these instances, make sure you call tech support, however. So keeping your z-axis in shape, good thing to do, which means you do the right thing after you have a failed print. You make absolutely sure that there's never any resin debris left behind in a vat and that your platform doesn't come crashing down on resin debris. And so that's something extremely important. So the platform, I don't know, I never tire of seeing a video of platform coming into my resin and displacing the resin. In this case, I think I have a surgical guide resin or a splint resin in the tray. I don't remember. Now it's a surgical guide resin. I just saw that on the screen, and so I can see the profile. This is the one where I was experimenting, but you can see how the resin just comes up around the platform there. Yeah, I don't know why I like seeing that. Supports. So we've talked enough about the build platform. We've talked a lot about the Z-axis. We've talked about how that could potentially contribute to failure. Supports are a big thing. Supports are about ensuring that a print is not printing its entire cross section in one layer. You can do that with some prints, but more often than not, you will find that Alpha AI will align things with supports, will align them at an angle. And some of these things print better when they're printed at an angle, because the cross section of what the printer is dealing with at any given time with one layer is then small, as opposed to something that's flat. And so supports are best generated now by the Alpha AI premium software. But when we had just Alpha 3D, we used to do a lot of manual supports. And then we used to see a lot of issues because not every user understood how many supports to have, how many supports to generate, what to take out, what to add, what kind of support structure to choose, whether he wanted structure or tree or all of these options that the software offers us. So the number of supports is important. The density of supports for unit area of the print, that's important too. The strength of the supports in terms of cross-sectional thickness of the supports matters. The structure of the supports matters in terms of whether there's interconnection between vertical supports, whether you have supports within the print itself, intermodal supports as they're known, and ultimately the contact point between the support and the print, and the length and thickness of the elbow before that contact comes in. All of these things matter. And you can be an absolute nerd and figure these things out for yourself with some printers, work with slicing software that's free, and be a completely manual man, and you can see more failures. Or you could go with software that's got AI built into it to help you orient your print properly, help you generate the right numbers of supports, right density, strength, structure, contact, whatever properties you're talking about. But supports are important. If you don't do supports right, then you do see support failures like this. So support failures usually occur just between the print and the supports itself. And invariably, these are because of poor orientation of a print. Insufficient supports in number, size, structure, strength, all of those properties we just spoke about, all of those can contribute to supports as well. Or if the contact angle of a support with the print is not great, then that can be a problem. This was a failure when I did manual slicing. You can also have unsupported areas in a print, and those are things you should look out for. You should always view your slices before you take a print forward. But usually with Alpha AI, it's got it all figured out. And sometimes with some prints, you may need intersupports. I see these commonly on the palette of a denture, for instance, and I think there's a picture of one in this presentation, and I'll mention it at the appropriate time as well. Oh, there you go. There you see in that central picture of a denture, that's the palatal side of the denture that you're looking at, not the intaglio, not the tissue side, but the outer side of the denture. And you can see that there are supports on the palatal part as well. And so sometimes you can have intermodal supports like that. But when you do supports right, everything works fantastic. I mean, upper left corner, that one's a splint. In the center there on the top, that's denture, nicely printed. Lower left again is another denture resin, printing beautifully. There's a few splints on the lower central picture. There's a few castable crowns there on the lower right. All of these are well-supported prints. On the upper right corner, you see what's commonly called a supportless print. And it actually has a build platform adhesion failure right there. And so you can see that happen sometimes. The drain hole with that model is also in position correct. I mean, it's not positioned correctly. If you're going to print flat to base like that without supports, you need to know what you're doing with drain holes, because otherwise resin will pool on the inside of a hollow model, and it won't cure, and it will give you all kinds of problems. So those drain holes have a purpose if you're going to be doing supportless printing. If you're a novice user, I highly recommend though that you stay completely with supported printing and you work completely with Alpha AI Premium's auto-generated supports. That's what the software is designed for. This is Medit software for building models, and it works beautifully to build bases, to build drain holes. You can do this kind of thing in most CAD software like Exocad, 3Shape, InLab, um, uh, 3Shape model maker. There's all kinds of software out there that actually help you create drain holes in the bases of models. And if you're going to print flat to base, then this is something you need to learn to do properly. You need to do properly as well. But otherwise, here's your easiest way out. It is so easy to stick with Alpha AI Premium and then do what the software generates, and you typically will not go wrong, because as I keep saying, that's what the software is designed to do. And if you get that right, then you should have very few failures. Julie, I just texted you there to ask if all was going good. I'm just not sure with no feedback, so just text me back and just tell me whether that's okay. So AI-driven orientation is very important with Alpha AI Premium, and with good success. This one there is a splint. And you can see that this splint resin is well supported with supports. There's interconnections between the supports. There's a great base as well. All of that's generated by the software, and it works seamlessly. You can also have other failures with prints that have nothing to do with supports. For example, the supports are okay here. There are a few supports that have failed right in the front, in the anterior. This print is incorrectly oriented, to be frank, and it would have had a high peel force, which is what would have most likely caused this failure. But you can have incorrect exposure settings of the light source. As it happens, this particular failure was caused because I fiddled with the exposure settings in Alpha 3D when that was possible. And yeah, I had a problem because I forgot to change the exposure settings. You can also have unsupported areas in prints where there are no supports, and that's something we talked about. You can see that the posterior part of the splint just never printed. The part that goes on the molars never printed. And if I review the support file, I found that there were very few supports in that area. But basically, if you don't orient correctly with a resin like the splint resin and with an orientation like this, you can have layers that have a fairly high peel force. And you can also have pooling off the resin if a print is not oriented properly, allowing resin to flow off. So all of these are possible reasons for print failures that have nothing to do with supports themselves. VAT issues. You could incorrectly align a VAT. We talked about that. Very difficult to do with the sol, but it can happen. More often than not, it could be because your z-axis is out of whack. Right here, you see a print failure where there's a layer of splint resin adhering to the film and it's off the platform, and so that's a failure. Sometimes you can have insufficient resin volume. And so it's interesting what causes these failures, because you learn more and more about 3D printing when you have failures, because each one of them is an opportunity to find out what did I do wrong and what can I do better. So VAT issues, yes, but very unlikely with the sol. Resin issues are big. You could have a bottle of resin that's off, that's past its date. You could have a bottle of resin that's been incorrectly stored. You could have a bottle of resin that hasn't been mixed properly if it's a fill resin. But the most common resins that love to fail are splint and guide and some of these transparent resins. These resins usually involve high molecular weight oligomers, and that doesn't make it easy for these resins. They tend to be viscous, they tend to be heavy, and they don't lend themselves to controlled precision of curing because they're transparent. So light can pass through them, so you can't kind of contain the energy of the light at a layer properly. And so manufacturers work very hard to generate the right profile. So with these kind of resins, be particularly careful to make sure you're selecting the right profiles and to make sure that you've oriented things correctly as well. Temperature is a big one. If you're going to store your resins if you live in a cold environment and you store your resins in a cold place, then the resin that you're bringing to the sol is already quite cold. You could argue that maybe we should have heating in the vat or heating in the platform, but quite frankly, if you store your resins in the right place and if you do your printing in the right environment, you really will see very few temperature problems, if any. Resin nuances in terms of orientation. For example, these are splints, and this is how a splint in AI is oriented. You can see that this basically means they're at a 45-degree angle. If they're at a 45-degree angle, then the actual cross-section of any one layer that's being printed at a given time is very, very small. And so as a result, you will have great success with orientation like this. And again, some of these resin nuances can be addressed by the AI software with regard to orientation. The film is important at the bottom of your vat. Sol used to ship in the past with what was called FEP films, but all the films now are NFEP films. I do see some suggestions online that you attempt to change your own film. I wouldn't recommend that because really these films are tensioned properly across the vat in order to make sure that you don't generate too much of a peel force, and that's best done in the factory. If you change your own film, you run the risk of perforating your film, damaging it, potentially having resin leak through it onto your LCD screen. And as I said earlier, that can be a very expensive affair. Really wouldn't recommend changing your film yourself, and you're far better off buying a new vat. It's really not that expensive. Just get yourself a new vat, and the new vats all come with NFEP film. Platform size is directly relevant to peel force. We talked about that, and we talked about print layer area as well, so I'm not going to go into that again. This was from the Ackuretta user group, and I've acknowledged the user group. It's a great source of knowledge. It's a great place to ask your first questions. It's a great place to go when things go wrong. It's a great place to share what you've learned from a failure experience because others learn from it as well. The tech support team is always watching the user group, so more than likely you get support as well, although you can contact tech support directly as well. But this user had resin leak out of his vat onto his LCD screen. That's pretty significant damage when he was trying to clean it. And we won't talk about what caused it, but you can have significant damage like this, and it can effectively mean even printer replacement. And so that's something you want to think about. Films are interesting. I actually turned the audio on in this particular video because you can hear the peel force. Did you hear that click? That click is the peel force. That's the layer detaching from the film and remaining on the platform. So it's a fairly audible click in that presentation, in that video, and you get a feel for what it's like. So one great thing to reduce peel force, as I said, is choosing platform sizes depending on your application, and that's something I encourage anybody I teach a lot to do and consider. The light source in the sol is a bunch of matrix LEDs. They do a fantastic job. They are very controlled. They don't generate too many problems that affect the LCD life. Conventionally, with LCD printers, you can get only about 2,000, 3,000 hours. The Sol, you can get about 10,000 hours out of these LCD screens, and it comes with a spare LCD screen as well if you ever exhaust your first one. Um, so light sources are important, and the Sol is calibrated, of course, with its validated profiles. The light source is calibrated to cure each layer correctly, and it works very well. I've not heard of anybody have a light source issue with the LEDs in the Sol just yet, but it is potentially something else that could go wrong. So you could have failed LEDs, you could have a failed LCD, and I haven't heard of either of these with any Sol user that I'm aware of. Yeah, so the other more common thing that you could see, like the left picture there of a print, you could have smudged film. And sometimes this is because film hasn't been cleaned properly after a resin has been poured back in the bottle. I don't even recommend that I don't pour resins back into bottles, but a lot of users do. I tend to be somebody who has different vats for different resins, and I only top up resin really. And I think that's the safest way to go. But if you're somebody who's going to buy one vat and you're going to swap resins out, make sure you clean that film really well with an alcohol spray and appropriate tissues in order to make sure that there's no smudges left on the film, because that can obstruct a light source. Let's talk a little bit about what to do when you have a failure, and this is critically important. Um, when you have a failure and you are suspecting that there's resin debris in the vat, make sure you go to the vat clean function. The vat clean function is resin dependent, and the Sol has the exact number of seconds that the LEDs will turn on for, and they will cure a layer of resin at the bottom of the vat in the form of a rectangle that is basically equal to the size of the light source. And so once that's cured, once you've done a vat clean function, take your build platform out and then take your vat out. And then right at the bottom of the vat, there will be a cured layer of resin. If you take something like a business card, not metal, something like this, that's stiff cardboard paper, you can lift up a corner of this and basically take out a whole rectangle of cured material. And the hope is, of course, that if there's any debris there, it will be trapped in this cured layer of resin and you can then get rid of it. However, sometimes there can be debris still left in the vat, and if you're seeing repeated failures, it might be worth going, pouring your resin back out of the vat back into the bottle, and then making sure you clean the vat and the film and come back from with brand new resin. But if you're pouring vat into the bottle, you don't want the debris to go into the bottle, so you must have a sieve filter of an appropriate size, and you can carefully pour the resin back into the vat. And after you've poured all the resin, make sure you use something soft like a silicone spatula in order to take off excess resin from the bottom of the vat, from the film. And then after you've done that, you can make sure you close your bottle. Of course, you don't want light exposure for your resin. You don't want to partially cure it. You can put that away, and then using a spray, you can spray IPA onto the film and use wipes and tissues to clean away excess resin. Make sure you get every nook and cranny that the resin can be hiding in. So yeah, we won't go into that in great detail, but you get the idea. Right, so I hope that's given you some kind of idea of why failures occur. And I think it's comprehensive enough to have included what you need to do when you have a failure as well. Hopefully you'll have less and less failures as you understand 3D printing better, as you ensure that you have the right environment and you take care of all those fundamentals that I spoke about right in the beginning. You will only have success after success. And that's really ultimately what I wish every one of you, a great user experience with the Sol and with the resins that are validated for it. Thank you very much for listening to me. I'm happy to get Julie back, and we'll take any questions at this stage.
Yeah. So thank you for your really comprehensive overview. I think there's always, and you said it right, you can have a full course on printing failures and all these little things. So as for a Z-axis calibration, it is in fact actually a very simple process to check it, but it's very important to do it properly because if you don't calibrate the Z-axis properly and then you start a print, right, you may cause bigger damage. So if you're seeing any suspicion in terms of that, always just send us a message. Slavomir and Harris are saying that we should open a WhatsApp group, and I'm not opposed to that idea. I think that might be great. But really, guys, the Acurata user group on Facebook is a great resource. um, and so join that, and we'll be happy to people provide feedback very, very quickly. Our customer success team's very active there as well. So, just jump into that one, and the WhatsApp group, we'll work on that. We'll see when we can make that happen. So we
Mhm.
did have some question, Nitish, and I'll throw them at you for a moment here. So the first question from Slavomir was about regarding the room temperature. So he's saying the room where his soul is not heated at night, and the temperature drops around 15 degrees Celsius. Does it have to be a minimum 20 degrees Celsius all the time, or just while printing?
Just while printing. Very simple. Yeah,
Yes.
easy one. Yeah.
Yes.
I
So
mean, even if you do have air conditioning, it's not as if you're going to turn it on all the time to maintain an ambient temperature of 20 to 25 degrees. So it's about when you're actually printing. It's a good idea to have the room at the right temperature and to have the resins at the right temperature as well.
yeah, I would say that as well. And I think just focus on, like, some resins need a little bit more heat to print well, need a little bit more higher temperature. So just focus on that. And it's usually, I think, the transparent resins that require that. So, as you're printing splints, maybe pay a little bit more attention to that, so that you have a good room temperature. But other than that, you should be absolutely fine in that regard. Great, that was easy. I mean, you already showed the clean VAT and platform function. Is there anything that you'd like to add? There's one thing I'd like to add on cleaning the
Mhm.
VAT is never use a metal object to take out any cured layers from the VAT. And we this one I can only say 1,000 times because we want to avoid that any resin really spills all over the LCD. Do you have
Yeah,
anything
and
to
you
add to
could
that?
also damage your film with a metal object, but
Yes.
with something like cardboard, like a business card, it's hard enough to lift the layer, but it's not hard enough to damage the film. So that
Yeah.
works perfect.
And all the new soles now that are coming out, and it's been going for the last couple of months, actually have a starter toolkit, which includes, a little tool to help you do that. So that's really nice. And that way you can just lift it up. But really, what it is like, a spatula almost that you can find in any kitchen store. So it's not a crazy expensive tool to add on.
Mhm.
Um, mhm,
There's a question on Beagle Varsia Smile Crown Plus.
mhm.
Um, yeah, you may not see the resin in your library unless you're updated. The firmware on your machine needs to be up to date. But you should see the resin in your slicing software, in your Alpha AI Premium. Uh, I believe you would see it there. The only thing that's unlikely to have that particular resin is the curie, perhaps. Um, but you'd have to check with tech support. You'd have to send in the serial number of your curie unit. Sometimes it's got to do with what resin profiles can be made available in what regions. But yeah, talk to tech support. And if at all that particular resin is not on your curing profile, it can certainly be manually added via the micro SD card that comes on Curie. Very easy to do.
Yeah, and I actually have to say the Versio Crown Plus should be on that Curie. So, you can always just, like, as I said, maybe you just send it into the user group and then we can check it out. On Alpha AI, you go to the drop down menu in the resin list and you go for bagel. So this is the important part. You may be looking for Varsio's Crown Plus, but what you need to look for is the resin manufacturer, which is bagel. And I'm going
Mhm.
to type it here in the chat. So look for resin bagel is the manufacturer, and then you should see it, and it'll definitely be there because this is a resin that we've already had in the menu for a long time.
Yeah.
Okay, we have more questions coming in. Can I do adjustments with a regular composite to a printed veneer? Not off topic.
I know what you mean. You're saying, can I add flowable composite to a resin veneer that's been 3D printed? Um, the answer is technically yes. They're not exactly identical materials, but assuming that the resin veneer hasn't been cured, it would definitely have an oxygen inhibited layer that you can bond your flowable composite to. However, on the other hand, if it's been cured, then you'd have to do something to condition that surface, maybe sandblast the resin and bond to it, and then yes, you can add resin. I've done that with crowns. I've never printed veneers, to be honest. Um, well, actually, that's not true. I have printed veneers, but yeah, I've certainly added composite to surgical resin guides. Don't ask me why, but yeah, I don't see why not.
Okay, Harris, let us know if that's answered your question, or if you have any follow-up questions, feel free to shout them out. Miguel De Leon. So first of all, nice to see you here, Dr. De Leon. Should we clean the vat with every failure, or is it okay to just remove the failed piece from the vat and try again?
I would suggest clean the vat with every failure because you have no idea whether you're leaving behind resin debris or not. Yeah, I know it seems like a waste of resin. I know it feels like you're taking out a whole rectangle of printed resin, but honestly, the volume's not large. It looks large in terms of XY area, but it's a very, very thin slice.
Oh,
Considering that it's hopefully going to prevent your next failure, um, yeah, I don't know. I prefer to use the clean vat function if every time I have a failure, sure that there's no resin debris whatsoever.
I think what we need to make sure here that is clear is that it doesn't mean that you have to pour out all the resin out of the vat each time that you have a failure, but
Oh
rather
no, no.
remix it. It's just take the cure the vat, clean the vat functions. And yes, I think what it cures in the end is probably around like 20 milliliters or something like that, like even at the most. Um, okay, we had one more question, and I'll be able to answer this one. Is the software included with the purchase of the Soul bundle? Yes. So anyone can download the Alpha AI, even if you don't have Ackuretta equipment, actually. So feel free to download and play around with it. And the Alpha AI Premium actually gives you the ability to use our slicing software and to export the STL. So if you're currently maybe not working with an Ackuretta printer, but you like the dental related software and these functions, you can use that and then export it even to a different slicing software to kind of go around having to use more complicated software, just to give some context on that. Then we had one more here. Okay, so Harris has a follow-up question. Do I bond the veneer crowns with regular crown veneer cement, or can I use etch and bond?
You don't need to use etch. Actually, it's interesting you asked me that question just yesterday. I was in a department of biomaterials at a local university in the US, and we were talking about bonding. Um, from what I understand from material science research, neither sandblasting nor silane nor acid make any difference. Using a good bonding agent does seem to make some difference. And even there, that doesn't seem to be a suggestion that an MDP10 containing adhesive is absolutely necessary. These things apparently bond extremely well. And so treat them just like you would treat composite resins, and do whatever you do with composite resin veneers. Bear in mind that if you're using milled composite veneers, that's a different animal. You sandblast those because you're dealing with fully polymerized resin. That's a bit different from a printed resin veneer. A printed resin veneer is not fully polymerized on its intaglio. At least if you post processed it properly, it shouldn't be. And so it's easy to bond to that, and all you seem to need to do is apply adhesive and use your regular resin cement, and yes, you'll have fantastic bonds.
All right. Thanks for the answer. So Dr. De Leon is already asking about our new curing unit, the Curie Plus, with the nitrogen cure, and if it's going to be faster than for packed rodent sculpture. So I can already tell you, yes, it will be faster. I cannot tell you exactly the numbers right now. Um, you would assume, like, you can assume that it's going to be about, like 25% faster, roughly. That's the suggestion I would give right now. But, I'll let you know when we have the actual numbers, um, which could be any day now. I have to check back in on this one. But yes, obviously, because of the impact that the nitrogen has on the object as you print, as you're curing it, that will actually speed up the process significantly. Yeah, and you'll be able to read a lot more about the Curie Plus very shortly.
Amazing unit, I'll say that. I mean, the whole idea that you can make nitrogen from atmospheric air is fantastic. There is one other product on the market that does this, but that one comes with a compressor. The one with Ackuretta has no compressor, and it's all built in into one nice compact unit that I had the opportunity to see. So yeah, very nice unit. Um, yeah, so I think it will make curing faster for sure.
Mhm.
But the jury is out there about whether it really adds any significant benefit to properties. But we will see better cures, though, no doubt about that.
And it's interesting that you're saying that, because obviously we're running testing on all of that, right? And we're working with the resin manufacturers on this, and they are doing the mechanical property testing. And I think you will be pleased to hear the results of this. This is as much as I'm saying now. And I think you'll all be pleased about hearing about the curing times as well. Because, yes, I think packed and rodent sculpture has a bit of an extended curing period on the current Curie. Um, and yes, we're speeding up these processes, so not to worry. I think the great thing about the Curie Plus is also, it's also fully automated, so things are coming downloaded without you having to do any SD card things. So it's just user friendlier, and I think 21st century, we're taking curing there. That's the goal. All right, I think we don't have any more questions right now. I don't see anything coming in. Nitish, I thank you so much, really, for your time and the effort you're putting into all of this. Um, Honestly, it's invaluable for everyone to understand that printing failures can happen, and it's not the end of the world. It doesn't mean you broke something. It just means that there's a little bit of learning involved, and I think that is an absolutely acceptable thing to say. I will say again that we have events coming up this next month. One of them is another wonderful webinar with Dr. Nitish Surathu on dental model printing. So if you want to sign up for that, I'll add the link again here in the chat. So sign up if you want to learn a little bit more. I think you're covering the whole process of model printing in terms of hollow printing and solid printing in terms of what are the benefits.
Mhm.
Oh, hey, 1 second. There was one question about the software that I forgot. If it can we close open models with your software? So not with the Alpha AI software, but I know there's some fantastic free software that lets you do that, right, Nitish?
Yeah, Mesh Mixer can very easily allow you to close a mesh. Not a problem at all. Very easy to do. I don't personally print too many solid models, to be honest. I print a lot of hollow models. I can't remember the last time I printed a solid model in my own lab. That has very little application for me. But yes, if you wanted to close a model, very easy to do with mesh management software like Mesh Lab or Mesh Mixer. Any of those will do that for you.
Yeah. And if you want to know more, if you've watched this webinar and you want to use this resource again, this will be also online on our YouTube channel, our Ackuretta YouTube channel. So feel free to check that out. Keep up to date with what we're doing. You can check out our newsletter, our website, or stay tuned on our Ackuretta user group or Facebook. So really, there's a lot of different options for you to keep posted, and we will definitely have a lot more informative webinars coming up soon. And so, as you're going through this journey, I think it's very helpful to use these little guides that we can give you. And yeah, we're really happy to be able to have this. And so thank you, Nitish, for being part of this. And one last event, if you are at Lab Day West, come check out Eugene. Nitish, you visited Eugene. I think you can speak for him being a phenomenal speaker as well. Very knowledgeable and just a lovely guy to listen to.
Yeah, Eugene's amazing. What he does with printed dentures, and what he does to produce beautiful looking dentures is just amazing. He's also a down-to-earth guy, very happy to share his knowledge, and yeah, very nice guy to meet and know. I want to say thank you to everybody who's logged in today, and I want to say thank you to Julie and Ackuretta as well for having me. I want to acknowledge Drake Dental Laboratory out in Charlotte, in North Carolina, which is where I am today. They've let me use their conference room, and you see this beautiful painting at the back. Uh, so yeah, great lab. They do some fantastic printed dentures as well, and it's amazing to see what they've done to their own workflows with printing. I always say, hang out with technicians. You'll learn a lot more. And I'm doing exactly that today. So thank you, everyone.
Thanks, everyone. Thank you, Nitish. And I hope everyone has a great day. Talk to you all soon. Bye.
Thank you. Bye bye.